Alright, hello, this is Trenton, and this is the dice game I made. Me and my friend Bellis had actually been working on how this game would work, but by the time the final project came around, we ran out of time. So I'm going to show off how it works, basically. Player 1 and Player 2 face off by rolling the die, or rolling 4 dice, 4 6-sided dice. It'll add up the total, and then do the damage. And of course, whoever hits 0 first loses. So let's do roll, see 11 damage, and you just keep rolling until player 2 wins. Oh, there we go. Player 2 wins. So I'll roll again. Player 2 wins. And you can also roll a few times, and in case there's any foul play involved, you can just hit the reset button and it'll completely reset everything. So yeah, when player 2 is having a lot of luck. So yeah, me and my friend we're hoping to add more options, like maybe being able to heal yourself or roll, or maybe every few turns the player rolls regardless of whether they want to or not. But like I said, we ran out of time, and I just had to make what we had planned out. I'll probably try and keep working on this after the semester's over, just to add the things, because it seems like it'd be fun. But for now, this is what I finished, so yeah, I hope you enjoyed. Okay, bye!
Okay, this is Tetris, my final project, and this is Riley Livingston. Just gonna kind of go through the code here a little bit. We've got the imports for all of the layout of the board and the border. We can go through the three classes we have here. Sorry, that are all nicely coded. And we're just going to start it up here. So as you see, the pieces fall down. Left and right arrows move the pieces left and right. And the up arrow rotates the pieces 90 degrees. And then we're just going to clear some lines here to show the game counter. Just going to wait for a line piece. There it is. And you can see that the lines add up at the bottom there for your score. Clear another one. And we get 5 at the moment. If you don't put the pieces down, get a game over prompt, and the game finishes. This is Tetris by Riley Livingston. Thank you for watching.
This is my final project for Computer Science 4DS, and it's called Apple Catch. And basically what it is, it's a 2D mobile apple catching game where the user is the basket and the user tries to catch the apples before they hit the ground. So the game starts off with a splash screen, and the splash screen just basically introduces me as the developer to the users. So let's play that. As you notice, there was a fade effect there, and then it quickly changes to the menu. Now, when at the menu, you see the title of the game and two buttons. The first button is the exit button, which works for mobile platforms only. It just closes the application. The second one will load the game scene for the user. And in addition to all this, there's 4 random colors of apples spawning in random locations all across the scene. So there's a yellow one, the next one is a green one, and another green one. So let's load the game scene quickly. So when at the game scene, there's a pause button right here, and when you click it, it changes to a play button. And in the pause menu, you see 3 options. The first option is to go back to the main menu. The second option is to reload the game. Say for example you're here and you know you're gonna lose, you can easily reload the button to save time. And the third option is to exit the game. Once again, this only works for mobile platforms. So let's try to play the game. And if you're not on a mobile platform, you can use the arrow keys to navigate the basket. Otherwise, you can use the 2 GUI buttons right here to go right and left. And you can see the small separation between both of them with this line. So let's get started. So they should be 4 random colors spawning across random locations. So there's 1, dead center, scores 1. There's 2. Let's keep going. You got 3 there. 4. 5. 5 is our current score, as it shows right here, and 6 is the all-time high score. I've played this game before, and 6 was the all-time high score I've gotten. And as you notice, the apples still spawn in the background, creating kind of a cool effect. And when the game over screen is loaded, it'll give the user one option, and that is to reload the game and basically start from scratch. So this has been my Computer Science 4DS final project. Thanks for watching.
My name is Thomas Batista, and I made a calculator in Java. To input expressions in my calculator, the user can use a keyboard or click the buttons to input the expression. For example, if I wanted to know what 53 minus 6 is, I would click the buttons to input the expression, and then click equals to get an answer of 47. I could also use my calculator, I could also use my keyboard if I wanted to know what 8 divided by 4 is. So I would type the expression and then press enter, and then I would get 2. My calculator could show a solution with steps for longer expressions. For example, if I wanted to know what 28 minus 9 squared divided by 3 minus 2 is, I would get 3, but if I wanted to know how I get there in the first place, I would check the checkbox that says step-by-step solution, and then I could copy the expression and then paste it there and then click equals. And then it's shown here that I must square the 9 first to get 81, and then divide it by 3, and then subtract 2, and then subtract 28 minus 25 to get 3. My calculator could also set values in variables using expressions. For example, if I wanted to set a value to x, I would go x equals and then input an expression, 21 divided by 6 squared divided by 9 minus 1. And then I would press set, and then it would show that I would square the 6 first to get 36 divided by 9 minus 1, and then 21 divided by 3 is 7. And then it shows here that x has already been assigned a value of 7. Now I could use x in other expressions. For example, x squared minus 2x plus 1. And then if I don't put a step-by-step solution, I would get 36. I could also use other variables in expressions which values get assigned to other variables. For example, I could put y is equal to 2x plus 1. If I set it, y is now 15. The calculator could distinguish invalid expressions from valid expressions. So for example, if I put 2 times parenthesis 8 minus 9, and then I forgot to put a closing parenthesis, it would say it's an invalid expression, and it would show that the expression either ends in an operator or has an extra open parenthesis. In this case, it has an extra open parenthesis. It could also distinguish mathematical errors. For example, if I try to divide by 0, so 12 divided by 0, it would output that I cannot divide by 0, and it's an invalid expression.
Hello, my name is Jaden Desereau. I'm a student at Sturgeon Heights Collegiate. This is my internal assessment project for computer science. It's an iOS app for car spotting. It allows people to take photos of cars, exotic cars, and share them within their network. Let's run the app. So the app starts off on the home page. It's a view of all of the what I call spots. You can see people can have two kinds of spots. They can have a photo or a map view. So for each spot in this feed, I can either like it, unlike it, or share it on any external networks like iMessage or email. I can click on a user's avatar to view their account and all of the spots they've made. I can follow their account and unfollow their account. I can swipe back to go to the previous view. If I'm in the app and I wanted to create a new spot, all I do is tap this middle icon at the bottom. I'm given 3 options to choose from. I can either select an image from my photo library, I can take a photo with the camera and view a grid, or I can choose a location on a map. The location it finds is not always that accurate, so users have the option of zooming in, tapping the marker, and manually moving it to a new location. They can then tap the next arrow, add a title, caption. Notice that the type says location, and we are given the coordinate data. Once we're happy with what we've got, we can click publish, then refresh the feed view, and notice that it's now here. I can click on the new spot to get a better view of the map and perform interactions on it. I can zoom in, rotate, and modify the camera angle. If I wanted to create a new spot with a photo from my library, all I do is select an image, click the next arrow, and do the same thing. This time it'll tell me that the type is a photo. I can add a title again, caption, and then I can publish. It's uploading, refresh, and there's the spot I just created. Let's say the current user has several different accounts. If they click the tab at the bottom that says switch user, they're given a list of all the users they can choose from. Tapping on one will notify you that you've logged in as a new user. Now when you create a new post, go back to the home view, refresh, a new spot under the user was posted. If I wanted to view the profile of the currently logged in user, I tap the profile icon on the bottom right. So this is the user I'm logged in as right now. I can view all their spots, view their biography, and all of their followers. That's about it for the app. Let's have a look at some of the code. So in order for this app to function properly, I needed to split it into 2. I need to create the app that runs on the device and a backend server which stores all the data. To create the app, I used a library called React Native made by Facebook. It allows me to write iOS and Android apps using the JavaScript language. I chose it because JavaScript is the one language that I'm most comfortable using. React Native uses a paradigm where everything displayed in the app is a component. You can see here, this app has about 35 components. We can take a look at the photo selector component to get an idea of how everything works. At the top, I'm importing all of the React Native APIs I'm using, all of the custom components and custom views. I'm even using third-party components that are open sourced. So every component is a class that extends React Native's component. These methods here are the inherited methods. So when a component is mounted, that's when it gets displayed on the screen. So in the case of this photo selector component, as soon as it's visible, I want to call this function and update the status bar. This getLastPhoto method references this method down here. It uses the built-in camera roll API to get a photo from the device. So in order to get access to data, photos, uploads, I needed to create a backend server. In this case, I'm using Node.js with Express and Mongo database. So inside my API.js, I'm importing the router object from Express. You provide the router object with a series of routes. Each route is a URL value. Within every URL value, you have get, post, put, and delete methods. So these methods listen for requests coming from iOS. So if iOS sends a request to this URL and it's a get request, it'll go to the Spot class and call the getAll function. So everything you can see getting accessed here is what's called a model. You can see spots, photos, likes, users. To give you an example of what a model looks like, we can look at spot.js inside the models folder. So a model is simply a mongoose object. You just have to specify every single property of it and then what type of value it should be expecting. I then save the model, then gets used by several route classes. In this case, it'll be spot.js inside the routes folder. So every route extends the model object, which is the object we just looked at. It has a series of static methods which correlate to what's inside the API file. So we can see we have spot.get. Spot.get will then call this function find by ID, which comes from the model. It'll populate this embedded data and then send back a response in JSON format. The iOS app then can convert the JSON format into something the user can see on the screen. So let me give you a better idea of how this works. I'm going to pull up the server logs and then the app running on iOS. Click on the star icon. We can see we just sent this put request telling it that we want to create a new liker. So this right here is the request. So once the server gets this, it sends data back and tells the app that this user has liked this spot. If I were to click the star icon again, we can see another request has been sent, but this time we are deleting. That's about it for this app. Thanks for watching.
Hello, my name is Amy Dunsford, and this is my Computer Science 42 IB internal assessment. For my project, I made what I like to call a library database where you can input books and have them displayed on a screen in a JTable. I called my program the Self Shelf. This is the main form, a GUI I created. It holds the JTable, add, edit, delete buttons as well as a search bar. The JTable displays books, which are sorted as a linked list. The JTable is sorted into 5 columns as title, author, publisher, publication date, and genre. The book information is sorted under each column, and each row is its own book. To add a book, you click add and type in the book information in each text field. So for example, the Blood Cell, author, James Goss, publisher, Broadway Books, publication date 2014, genre, science fiction. Press OK, and it shows up there in the JTable and the linked list. To edit a book, you select the book you wish to edit, change whatever needs to be changed. Press OK, and it all changes in each of them, under each column. The delete, you simply click or select the book you wish to delete, press delete, and it gets removed from the linked list. For the search bar, if you wanted to search for an author you like, publisher you like, genres you like, you can simply type in what you want, press enter, and it will limit the JTable to just those things, the books with the parameter you want. After each button is pressed, like for add, once you add a book and press OK, the new book gets saved. The new book gets saved and added to a linked list that's stored in this library books.txt file, and which is why that when you can close the program and play it again, it will save and open up, read your file again. I created the JTable using a class called books table model that extends abstract table model. It basically just sets the row count and the column count, and it just creates a GUI, which is called in this display logic class that extends or is the logic behind the display GUI, which is the main GUI that includes the JTable. That is my computer science 42 IB internal assessment.
Hello, I am Ben Ma, and this is my computer science internal assessment. The objective of this game is to get the highest score possible without losing all your lives. Every time you get hit by an enemy object, the aliens, you will lose 1 life. To move, I use the W, A, S, and D keys, where W is up, D is to the right, A is to the left, and S is down. When I collide with an asteroid, you will not be able to collide with it. You will just stick to the object. Each object in my game has custom animations that will run constantly through the game. When I left click, a bullet will be shot at target location where the mouse cursor is. If I hit an enemy, there will be a score increase of 100 and that enemy will die. The asteroids have random start locations every time you start the game. You can see the collision with aliens here. My score increased by 100 every time it shot. Once the amount of lives hit 0, your character will die and the game will be over. The aliens have random spawn sizes and spawn locations, and a random spawn chance. If I collide with one of the enemies, I will lose life. My drawing and graphical user interfaces are done with buffered images and threading. The thread runs the draw method, the create method, which draws all of the objects on the screen. The animations are played using the animation class, which each object in my game has a separate one. There are variable arguments to this, and you can input as many images that you would like to loop. The images are gotten from the getImages class method, where there are 4 different images for the UFO, and that's what I'll loop through. If I play the game again, you can see that each one of these asteroids had a random spawn point different from the last time I played. And the aliens will not spawn in the same place either. I use linked lists to store the bullets and enemies classes, since there can be an infinite amount of bullets and enemies on the screen at the same time.
Hello, my name is Jaden Reich, and this is my computer science IA. This is a game of Go Fish. It's rather simple. As you can see here, it records the point. It records the total number of points you have. The game is composed of several classes, starting with the final project class, which is where everything is compiled so the game will run. For here is the player class, which creates both the user and the computer classes. This also creates all the cards used in the game. The user class creates an instance of the user so that they can play. It records their points and their cards. The computer class is rather similar, except that it requires absolutely no user input and records everything relating to the computer. The dialogues classes contain all the outputs, and so it allows the graphics of the game to run. The linked list class is used for the cards of both the user and the computer. This is one I created myself. In addition, here the node class is used in conjunction with the linked list class. This is also something I created, and so the program also has error checking, allowing the user to cancel at any time. It also checks to see if your number is valid. Should the program run into an error, it will stop. But however, run success. So upon the successful completion of the game, it does allow you to play again. And that concludes the entirety of my IA.
Hello, my name is Kaylee Simon, and this is my Computer Science 42 IB final project. So I decided to make for my final project a simple Java game with simple graphics in the style that my friend's little sister, who is my intended client in this project, really enjoys to play on sites like Miniclip. So these games have very simple graphics, very simple mechanics, and are just sort of easy fun. So my project is called Apocalypse Simulator and is made in that style. So let's get started. So it has a little opening screen that's timed there. Alright, so when we open it up, we get to this menu. So we're going to start with the tutorial so that we can learn how to play. And this takes a moment. because it's got a lot of stuff in it. There we go. And this stays here so we can exit the tutorial at any time. And we hit this button at the bottom to go to the next screen. These are the J labels that I will also be using in the game itself. So you need to take these labels and sort them into these boxes. These are the lives labels, the life tracker in the bottom. So this is 3 lives, 2 lives, and 1 life. Alright, so let's move on to the game itself. So this end game thing does the same thing as when the game itself ends, when you lose all your lives, or when you hit endgame in the menu. So I will show you what that does later. So let's get started. So here is my basic frame. So we've got the 4 boxes in the bottom. We've got our lives tracker here. We've got a menu button here. And we've got our score and the number of objects that we've correctly sorted into the boxes tracked here. So these aliens are worth 50 points, as are the plagues. The comets that go in here are worth 25 points. Pardon, these are not aliens, these are zombies. The comets that go in here are worth 25 points, and the aliens that go in here are worth 75 points. So let's play a little bit. So I have this button along the bottom that pauses the spawner, so there are no new falling objects spawning up here while this is happening, and also pauses the movement of every falling object on the screen. So let's play this. So we drag them into the correct boxes, and as you can see, our score goes up and the number of objects that we have successfully repelled goes up. If I just hit the menu button for a second, if the game is already paused, the menu button doesn't pause the game. But if the game is not paused, as I will show you, so if you hit continue, it just goes back to the game and unpauses the game. But if the game is not paused, the menu button pauses the game. So now in here, I have the ability to start a new game or end my game. So we're just going to start a new game just to see how that goes. So it closes the J-frame, reopens that title screen, and reopens the original menu. So we're going to hit the new game button again. And I'll just sort a few of these for a second, just so we can get an idea. Alright, so now I'm going to sort the objects into the wrong places. I'm going to sort this alien into this black hole, which is intended for comets. And I'm going to sort this comet into the auditions, which are intended for zombies. And we're going to see what happens. I want you to watch this lives tracker down here and see if it changes properly. Yep. And when we only have 1 life left, it pauses the game and activates the last chance sequence. So it randomly decides how many items to remove and then removes them from certain boxes. It decides if the boxes have, it doesn't decide. It checks if the boxes actually have items to remove, and if not, it moves on to the next box. And then it multiplies the number of items removed by the number of points in the box, the number of points that that item is worth, and removes that many points from the point tracker down here, and removes these items from the point tracker down here. So as you can see, my objects repelled has gone from 4 to 2, and my score has gone from 250 to 100. So let's just let that one go in here. And this is the ending sequence. Now it tracks the number of objects that you put in each box and displays that just so you can get a little summary of how you did. This was at my client's request. She wanted to see how well she was doing, and it displays the point value. And now we can choose to either hit no, which activates the same sequence as the end game in the title menu and the end game here, or we can hit yes. So I'm going to hit no so that we can just see what the ending screens look like. So we get this, and then we're done. All right, so I'm going to show you now a bit of what I did. So first of all, one of the things I am very proud of in this project is my own linked list and nodes class, which you can find in the collections package over here. So I made these classes with the help of my instructor when we were learning about linked lists. Instead of just learning how to use the files already, the library already created by Java, we decided that we would create our own. And so we can add a few things that are really useful, in my opinion, including being able to make a linked list from an array, from another linked list, being able to, create from an array, transfer a linked list to an array without having to go through all kinds of looping in your code. You can just call this toArray method. And we can also create sublists and other such things. We can retain apologies. We can check if it contains an array of items. We can, and then we can do all of the things that are done by the linked list class in Java. And so our node class isn't anything particularly special. It's basically the same as the nodes created by Java, but it was just easier to, since I had my own linked list class, I might as well have my own node class that I am free to modify whenever I so desire. So another interesting thing that we have in here is my game constants class. So I made this to allow easier access to all of the constants in my game without having to pass them to and from all the different classes in all the different packages. I can just have them all import this one class in my tools, and they have everything that they need. So we have all of our image files, including the path and the extensions for the PNGs, and then the path for the GIF at the end. We also have our falling object constants, how much they move, and how much the delay is in their movement. We also have some miscellaneous constants, including the colors for the background, the buttons, the pause button, the fonts, and just our sizes of our J-frames and the coordinates of things that do not move. The other thing that we have in the game build class is our coordinate class, which is very useful with falling objects and with other objects just in general, and supports my game object and game character classes. And so we have each object has its own set of coordinates, which we can just modify in here, and then if we want the coordinates to move up or down, we can just call from here instead of fiddling with the coordinates. So I also have a utility package that contains the numbers. That's just my random integer class. method, which I use when I'm spawning which kind of object I spawn. Also, when I am deciding how many objects to remove and from which boxes. Alright, so connected to my coordinate class, I also have a directions class, which obviously has the different directions and helps the coordinate class in its functioning. Then we have sort of our main classes. The variables and the size and the style of the grid are set in my game grid class, which we'll just take a look at. So we've got all the labels. They're all set. All the image paths are made into labels and icons for the pause button and the end screen. We set the look and feel of the grid, and we add the labels. And then almost everything else is in my game engine, which is past all of those labels from the game grid and the grid's container and the grid itself. And then we spawn the boxes. Here, let's just look at in here. So we set all the variables. We create the boxes, the bottom wall, the linked list, the pause buttons, the menu button, the spawn timer. We set the variables in here, right here. And we set the lives to 3, which is the starting amount of lives. No points, nothing in the boxes, and it is not paused. And then we can spawn all of our objects and then start the spawn timer, which is in the, so the spawn timer can be seen here. And so when the action event occurs, it activates the spawn falling object method, which creates a JLabel, randomizes which kind of falling object it is out of the 4 types, then activates tells what type it is from that number, and then acts accordingly and adds the falling object and sets it where it needs to be, and then lets it fall. Spawns it, lets it fall, and adds it to the on-screen linked list. So it is on screen now. And the linked list keeps track of that for the pause button, which has its own class here, as it has a special functioning. And so for the action for the pause button, if the game engine is not already paused, then it's now paused. It's activated that it's now paused, so that other objects such as the menu button know that it is paused and that they do not need to pause it. And it pauses the falling objects, and it also pauses the game engine timer, which was in here, which stops the spawn timer. That's all very exciting. My tutorial and such are nothing super exciting. It just, when the button is pressed, the screen number goes up, and so it starts at 0. Screen 0 is the welcoming screen there. And we have, excuse me, all these screens activated, so they change the labels, they set what's visible in the container. All the labels are attached to the container permanently, but they set them visible or not and set where they need to be, and set the text of the label in the middle so that the when the next button is pressed, the game does not need to totally recreate the JLabel, it just needs to update what is in it. So every time the next button is pressed, the number goes up, and then it activates this next screen area. All right, so I think that's everything. Thank you very much for taking the time to watch my video. I hope you enjoyed it, and goodbye.
Hello, I'm Joseph Singh, and this is my IB Computer Science Internal Assessment. For my IA, I decided to create a game similar to Space Invaders, which I titled ONGMOS. The objective in this game is to defeat the oncoming waves of aliens without being defeated yourself. Once all waves have been defeated, the game has been won, and it resets itself. If the player takes too much damage, either from colliding with the aliens' bullets or the aliens themselves, the game is lost, and it resets itself. As you can see here, a title screen appears when the game is first launched, prompting the user to press a key. Once a key has been pressed, the game starts. The player controls their spaceship through the use of the arrow keys and fires their machine gun with a space bar. The player can also tap the V key to shoot a large laser beam, which pierces multiple aliens. These, however, have a limited number of shots. In addition to animating for movement, the player's sprite will flash white if hit, and their health will decrease by 1. When one of the outer aliens reaches the edge of the screen, the whole wave will accelerate and move downwards. When a new wave spawns, all of the aliens in that wave fire at once, in order to increase difficulty. Here, the game has been won and reset. As explained previously, when the player's health reaches 0, the game is lost. See ya later, Space Cowboy. The aliens in my project all inherit from an abstract superclass, shown here. This allows new kinds of aliens to be created easily and efficiently. The waves in my project are handled similarly, with an abstract superclass serving as a base for all of them. This means that creating new waves is as simple as copying one of the previous ones and instantiating it in the game screen class. This has been my computer science IA, ONGMOS. Thank you for watching, and may
I'm
the
a
force...
developer from Canada, and this is my internal assessment. I was approached by a local store owner who requires a complex inventory system for their business. He's wanting my assistance in this endeavor. However, he has asked for a prototype before pursuing this endeavor any further. He is looking for speed, not to mention cost effectiveness. To align with the client's wishes of speed, I've chosen to go with the popular NoSQL database language called MongoDB. A NoSQL database is highly scalable with the performance to meet almost any demands. So keeping with the performance, the prototype has been coded in JavaScript, running Node.js as the engine. Combined with these technologies, I am certain that the client will approve of the prototype. There are two parts to the prototype: the front end, which is here, and the back end. The back end serves as the API, or the application programming interface. The API interacts with the MongoDB database server. Well, the front end is where the prototype orchestrates the request to the API. Create, delete, list, and so on. The front end checks that the back end is online before it goes along with the prototype demonstration. This ensures that no severe errors could occur from sending requests to an API that is not currently online. Just to illustrate this, I'm going to actually run the front end without turning the back end on first. And as we see, the front end gracefully exits from executing the demonstration because the backend could not be contacted. This action is built into the submodule I created called request.js. Before the class executes any HTTP request for the demonstration, it first checks to see that what you want to contact either A, exists, or B, is online, i.e. it does not throw any HTTP error codes commonly used, like 500 errors or 502 errors here. Now let's actually run the prototype. I'm going to run the backend on first, starting here. As we see, the backend is online. Now the front end. Okay, lots of things happened here, so let's break it down. Before the prototype initiates a demonstration, it checks the backend as we discussed. This is called the startup. It is determined that the backend is online and available, shown here. Now, if we look at the main executing index, we see that once the startup says all good, we move on to the core processes. This is where the demonstration is housed. Again, once the startup has completed, it starts to run the demonstration itself, which is here. If any errors are caused while the startup has initiated, it does not attempt to run the demonstration and throws all errors possible. Next, the core runs through the demonstration for the client, illustrating to him that there are alternatives to purchasing large, expensive inventory management systems. We see here that several functions are being executed. I'll just show you this. We have two main functions being executed: command procedure locations and command procedure products. The first one here executes all commands to create and list the location, demonstrating the usefulness of having locations in an inventory management system. This is shown on the backend as well. We can see that we can see this if we just scroll up from the output. As we see, a new record was created, location. We are calling this function here. Now, if no errors occur during the entire demonstration, the prototype exits properly. How this is gone by is each function has a choice to actually throw errors that occur. If none throw an error, it passes to the next one here. Same thing happens for command procedure products. If no errors occur, the final callback is thrown, allowing the program to gracefully exit. A side note, I wrote not only the HTTP request submodule called request.js, but the submodule sout.js. This is a complex class that easily adds styles to the console.log. It helps me as a developer to keep the console clean while it gave the client a better view into how the prototype worked. This is the entire sout.js class. I found it easier to write a class where I could have all functions running housed under one class instead of rewriting very simple tools on numerous files. I'd like to take a moment now to actually talk about how the two technologies that are used in almost each file I've written: promises and callbacks. I'm actually going to go to the startup procedure here to explain callbacks. No, sorry, promises. Promises are another way to actually provide error handling on a complex level. They're similar to try-catch blocks. Promises are written very similar to some common error handling syntax here. It's actually a class. There are two parameters: resolve and reject. Resolve is executed if whatever function is within the promise class had no errors in it. Reject is executed when there is an error and you must show that error to the program. If we go here, we see that I have my starter procedure here. We check for the backend ping, and then we have a closing method that adds to error codes. Each promise has error codes built within them, so you could actually have an object string along as you are running through your program to add to it. So you can have more than just one error outputted. You can have several errors if there are several errors, or thousands if there are thousands. It greatly reduces the time on debugging when you see more than just one thing happening at once. With all this information and the severe amount of error handling provided, the efficiency and the cost effectiveness is such a program as this, the client has chosen to work with me to build a custom product for him instead of purchasing a product online or through IBM. This has been my internal assessment for my grade 12 IB computer science class. Thank you very much.